6.NS.7. NS7 is comparing and ordering rational numbers. Now, in order for us to do this, we need to understand how to take fractions and turn them into decimals, because sometimes ordering these fractions can be a little bit easier when they're in decimal form. Because if they're in fraction form, we have to make sure that the denominators stay the same. Now, you can use whichever method you want, changing them all to same denominator, or changing them all to decimals. It doesn't matter as long as you understand the process and you can do it fluently back and forth. So we have 3/10 here. With 3/10, this is the same thing as a fraction bar. This line, this is the same thing as saying 3 divided by 10. So we're going to put 3 divided by 10. 10 cannot go into 3. So we're going to put a decimal and drop a 0. Now, 10 can divide into 30 3 times. 3 times 10 is 30. We subtract and we get 0. So that gives us 0.3 or 3/10. Now, that should make sense because as a fraction, we call this 3/10, and as a place value, we call this 3/10. They are the same thing. Here we have 3/5. 3/5 is the same thing as saying 3 divided by 5. So 3 would go as our dividend and 5 is our divisor. 5 cannot divide into 3. So we're going to drop a decimal. I'll put a 0 there. Drop a decimal and a 0. Now 5 can go into 30 6 times. Then we subtract our 30 and we get 0. So 3/5 is the same thing as 0.6 or 6/10, because when we change, just say we change our fraction to a denominator of 10. 5 times 2 is 10. 3 times 2 is 6. So that gives us 6/10, which is the same thing as 0.6 or 6/10, which is the same thing as 3/5. All of those are equivalent, just written differently. Now we're going to look at a mixed number. Mixed numbers can be done two different ways. One way is we can change this into an improper. 5 times 1 is 5, plus 2 is 7, so we get 7/5. Then we can divide and say 7 divided by 5. 5 can go into 7 one whole time. We subtract and we get 2. Put your decimal and drop a 0. 5 will go into 20 4 times. So that gives us 1.4 or 1 4/10. Now, again, we can also just use the fraction because in a mixed number, this 1 is already a whole number. We can go ahead and put that in the whole number spot. Now just use the fraction 2 divided by 5. 5 cannot go into 2, but we can put a decimal and drop a 0. Now 5 can go into 20 4 times, so it gives us our 0.4 or 4/10. So again, we normally put a 0 there because that's a place value holder, which is fine. But remember, with this being a mixed number, it already has a 1 for a whole number. So we're just going to take our 0.4 or 4/10 and place it behind the 1. Either way, it's still the same thing. It's up to you whether you want to make it improper and then divide or just divide the fraction. But if you do just the fraction, don't miss the whole number. Don't forget that it's still there. That's a big misconception. All right, so least to greatest. Now, if you notice on these least to greatest, we have 2 decimals and a fraction. The easiest thing that we could do here is to take that 7/10 and change it to a decimal, then order them. So let's look at this. We're going to do 7 divided by 10. Well, 10 cannot go into 7. It's an awful 7, but we're going to go with it. So 10 cannot go into 7, but it can go into 70 7 times. So that's going to be 70, and we get a 0 there for a remainder. So 7/10 is the same thing as 0.7 or 7/10 as a decimal. Now we're going to order least to greatest. So our 0.4 or 4/10 would go first. Let me clear all of this out so we can, clear this out. I'm sorry it's taken so long. All right, so now we can put this in order. We get 0.4 or 4/10 would be our least amount. Then we're going to use 0.6 or our 6/10 as our next. But now notice right here, I'm not going to write 0.7 or the 7/10. I'm going to write it as 7/10 as a fraction because that's how it was given to us in the problem. So we're going to put 7/10 as a fraction. Rewrite it using what they gave you in the problem. We know that 0.7 and 7/10 are equivalent, so you don't need to put the 7/10 as a decimal. You need to put it back as the fraction that they gave it to you in. All right, on this one, we have one fraction and two decimals as well. The easiest thing to do here would be to take this fraction and divide it. So we're going to do 1 divided by 4. 4 cannot go into 1, but it can go into 10 2 times, which is 8. Subtraction, we get a 2. We're going to drop another 0. 4 can go into 20 5 times. Now, another way, we can automatically just know that 1 fourth is 0.25 or 25 hundredths, because when we look at these as a quarter out of $1, that's going to be 1/4 of our dollar, which is 25 cents. So it depends on how you want to look at it. But if that is kind of a struggle for you to understand right now, just know that you can always say 1 divided by 4, and you're still going to get the 25 hundredths as the decimal. So now we're going to look at least to greatest. Look at this first digit, the tenths place. We're going to go back to elementary school for a second and talk about that tenths place. The amount of decimal places that you have does not necessarily make it greatest or least. A lot of times students like to look at 0.5 here, this 5/10, and say that's our smallest number because there's only one digit there. Not true. You have to look at the place value. So right here we have 0.2, we have 0.5, 0.7. Think about this as money. We got 20 cents, we got 50 cents, we got 70 cents, because we're only looking at that tenths place right now. So which one is our smallest? Our 20 cents is the smallest, but we're going to put in the fraction first. Make sure you put in the fraction how it was given, not necessarily the decimal. Then we have 50 cents, which is going to be our least. So this one just so happened to be in the exact same order that I needed it in. So there's our least to greatest. Let's do one that's greatest to least. Now this one's very important because you are going to see these a lot. Even though these two decimals look like they're the same thing, they are not. And we'll get to that in a second. But let's change this fraction to a decimal. So we're going to say 2 divided by 5. 5 cannot go into 2. So we're going to put our decimal, drop our 0. 5 can go into 20 4 times. So that leaves us with a remainder of 2. So 2/5 is the same thing as 4/10 or 0.4, however you want to look at that. So now we get to look at this and figure out which one is our greatest. Well, obviously, the 2/5 is our greatest because it's 0.4. That'd be the same thing as like having 40 cents. Now, let's look at these two. These two are very important. They're not the same, even though they look like it. The first one would be like having 30 cents, because behind this 3, we can drop a 0. We can add as many zeros behind the 3 as we want to. It's not changing the value. Now, this 3 is a little different. Behind this 3 is not a 0. Because we have that bar notation, what that means is that 3 is being repeated over and over and over. So we're going to put a 3 behind the first 3. Now, if we needed to take it on to the thousandths place, we could do that. We could just add another 3. But behind this 0 would be another 0 and another 3, another 0, another 3. So they're not the same value. That's 30 cents. This is 33 cents. So just know that that bar notation means behind that number that the bar's over is going to be a repeated of whatever that bar's over. So our next one is going to be 0.3, because that would be, or 3/10, because that's talking about our 30 cents, if you want to look at it that way. And then the next one will be our 3/10 with a bar notation, or we could say 33 hundredths, or however you want to look at that. We could just think about this as being 30 cents and 33 cents, and that may help. But just remember to take your fractions and turn them into decimals, which may be the easiest, not the only way. But if you keep them as fractions, the denominator must be the same, and they must stay equal throughout.